Hello students, welcome back. Our game here is almost complete. In this video, we're going to add some final systems to our game that take it from that beginning state of completely unplayable back in lesson 1 to our final complete game here in lesson number 8. And these systems are going to be primarily visual systems, so we'll call them our game polish systems. The first thing that we're going to do is we're going to add an overlay to our screen, a flash effect of a dangerous red color anytime the player gets hit by an enemy. This is going to give us some visual feedback that hey, you better watch out, you are taking damage. Then what we'll do is we'll add a visual effect so that anytime our enemy moves into one of our light zones, they'll undergo a burning effect. We'll change their color from the red that they normally are to some maybe white color to indicate that they're on fire. And in doing so, we'll begin to reduce the enemy's health. And this burn effect is going to allow us to have a mechanism that finally defeats an enemy so the player can fight back. And then third and finally, we're going to create a particle system so that when our enemy dies, it doesn't just disappear, but instead it explodes and particles travel out in all directions, sort of like fireworks. It's going to look super cool and it will be extremely satisfying when we defeat our enemies. So let's head over to the computer screen and let's dive right in. I have lesson 8's starter file open right here in vscode.dev. I'm going to minimize my browser here, and I'm going to open up that file directly in the browser. So I'm going to go to my Glowfield folder, and I'm going to open up lesson 8's starter file. So now I can see the changes that I'm going to make in real time. Let's see the state of our game currently. All right, so here I am in the light. Here comes an enemy. When they hit me, I get no overlay. All right, so that system's not there. My enemy's not burning in the light either. Ooh, but look at that. There is an overlay happening when I'm move into the darkness. It's like my screen dims when I move into the darkness, and it brightens up when I'm in a light source. So it's sort of like we've got some visual polish already happening. That's really cool, right? I'm in the dark. I'm in the light. I'm in the dark. I'm in the light. I'm in the dark. I'm in the light. So that's pretty neat. We'll look at that system that's already in place and maybe try to mimic it as we build our hit flash overlay. So when I take damage here, I should be seeing an overlay to the screen. So let's head to our code and get into building these systems. So lesson 8, our game polish system. Mission number 1, we want to adjust the polish constants. So no surprise here. Hopefully you're seeing that anytime we implement a new system into our game, we're going to put some constants here that we can use as knobs to control that system, right? We can tweak and edit them in our student edit zone to change how our game plays, looks, or feels. So we've got our player system, our lights system, our health system, our ramp system, our enemy system, our orb counts, and now we've got our polish system. So the first thing that I have here is a constant that's going to control how much damage per second the enemy is going to take when they are in a light zone. Ooh, so this is going to help us with our burn effect that we're trying to create. So how much damage do we want them to take? Well, how much health does an enemy have? If I look at my enemy system, my enemy has 100 health. All right, so that's pretty good. So 100 health. I'm gonna subtract. They're going to take 20 damage every second. So that means they would need to be in a light zone for 5 seconds in order to fully burn and be dead. All right, then we have a hit flash duration. We know that when an enemy hits us, we're going to create an overlay on the screen, or like a red overlay that says, you're getting hit, you're losing damage. How long do we want that overlay to last? I want it to be really short, so I'm going to do 0.15 seconds. And then we have some constants here for our particle system. So when we defeat an enemy, we're going to spawn a bunch of particles. How many particles will we spawn for an enemy when it's destroyed? I'm going to pick 40. And then those particles are each going to move at their own speed. So just like with our enemy, we set a minimum speed and a maximum speed, and then we randomly selected a value between those. We're going to do something here for our particles. I'll say the slowest particle could be 80 pixels per second. The fastest particle could be 500 pixels per second. And then those pixels are only going to live on the screen for a certain amount of time. I'll have them live for a half a second. And then they need a size. I'll give them a size of 6. So there are our constants. Now, before we go on to mission 2, let's see what else we have here for constants. If I look at our color palettes, we have an enemy burn color. Okay, so this is the color the enemy is going to be when they're in the light, experiencing that burning effect. And that color is white. So just FF, FF, FF. Give me all the red, all the green, all the blue. So we're going to make them and have them burn a white color. And then we've got some colors here for our, it looks like our hit flash color is going to be a transparent red mainly. And then look, we've got our dark dim color. So remember, we were dimming the screen when we entered the darkness. And so that must be this color. Let's have some fun. Let's mess with it. Let's set this to be like 100 in the green and 100 in the red. What's that gonna make when we enter the darkness now? So instead of doing an overlay of black, it's this gross like mustard yellow overlay. Maybe that's like we're entering like fog or like smoke. Let's just do like a green, a super green overlay. What's this gonna be? I'm just messing around. Maybe like this could look like we're entering like a cloud of acid. Oh, that's kind of neat. Like we've just entered a cloud of acid and that we get this overlay. So, maybe I'm just thinking of like another game where, there's like, I don't know, some bomb that goes off and it releases poison into the air, and now we're moving through it. So that's a neat little feature there. But it doesn't fit our game. We're moving in the darkness. So let's set that dark dim color back to 0. All right, and let's go look at our gameplay variables. What do we got for our gameplay here? Okay, so we've got 2 new variables to work with. The first is a timer that's going to control our hit flash. So right now it's set to 0, and when we want to show our hit flash, we'll change it, and then we'll set it to like 0.15 seconds, and then we'll just decrease that, and when it's back to 0, we'll stop the hit flash. And then we've got a container or array for all of the particles that we're going to make. So those, I hope, are pretty good. It's kind of like what we did here with our enemy system. We've got a container and a timer, and we're going to use them in the exact same way. So let's head to mission number 2 now. Mission 2. What's it asking us to do? Well, it puts us in our reset game to defaults function. So this is going to run anytime we start a game or play a game over, and it says that we need to reset our polish variables. So we're going to clear out our particles. So if there were particles that were already on the screen, we want to get rid of them. So I'm just going to do particles. That's the array, the container that has them all, and I'm going to redefine it as an empty array. So perfect, we cleared out the particles. And it says reset the hit feedback state. So remember we had that hit flash timer. So hit flash timer seconds. So if there was a value in it, like if we had just set it to be like 0.15, when we start the game, we don't want the hit flash to be appearing at all. So we need to set that timer and set it back to 0 to say like, hey, we're not running this right now. Mission number 2 in the books. So mission 1 is done. Mission 2 is done. What's mission 3 going to have us do? It looks like we're going to target our hit flash here in mission number 3. So mission number 3 is asking us to trigger the hit flash effect. Set the timer accordingly. All right, so where are we? We're inside check player enemy collisions. So for all of our enemies, we're looping. We're going to check to see if the enemy can actually deal damage based on the enemy's cooldown. And if they can, we determine where they are in relation to the player. And if there is a collision between the player and the enemy, we've already written this out, right? We're going to set the enemy's cooldown, deal some damage, check to see if the player is dead. But now we want to trigger our timer. So our timer was set to 0. We don't want to keep it at 0. We instead want to bump it up to some value. And we're going to bump it up to the value that we set here, hit flash duration. So right now, when we get hit, our hit flash timer in seconds is going to be 0.15 seconds. So maybe we'll actually see an overlay now when we get hit. Our darkness overlay, working. Good, it's not that green smoke anymore. Let's get hit by an enemy. Oh, come on. No overlay. But we set the timer, so why is it not working? Well, I don't know. Let's go down to our draw functions and let's see what's happening. So we have this timer set. So this is good. Our timer is set. All right, and let's go to draw scene. We draw our background, our lights, our orbs. We're drawing our particles, so that's good. So when our particle system's set, we're already drawing it. We're drawing our enemies, our player, our HUD. And if you look here, here are all our overlays. We've got our overlays for start and lose. Here is our darkness overlay. We're drawing the dark dim overlay. Look, it says if not player is in light. So as long as the player is not in light, and that is what we're seeing here, if I'm not in the light, I draw the dark dim overlay. Ooh, so that's working. But we're targeting the hit flash overlay, which is right here. And it says, hey, if hit flash timer seconds is greater than 0, draw the hit flash overlay. Well, we just set the hit flash timer. It is greater than 0. It is equal to 0.15 seconds when we get hit, but we're not drawing anything. So let's go to the draw hit flash overlay function. So I'll scroll down through my draw functions. Eventually, I got to hit draw hit flash overlay. Ooh, here it is, draw hit flash overlay. And look at that. That brings us to mission 4. We logically jumped through our code to get to the next mission. So mission 4 asks us to draw the hit flash overlay. We got to draw the hit flash and use the correct color. All right, so what are we doing? Well, the first thing we do is we say, give me a marker that is invisible so you don't see the outline of the shape that I'm about to draw. And now I got to draw the shape. Well, let's just peek down at the draw dark dim overlay because that's working really good. It looks like we got to put the right paint in our paint bucket, and then we just draw a rectangle over the entire screen. All right, let's do that. Let's do the exact same thing. So no stroke was already called. So now I'm going to put some paint in my paint bucket, and I'm going to put in, I think it was called hit flash color. Yeah, it was a red color, right? Yep, if you look there, it's going to be a transparent red. 255 in the red channel. Give me all the red. And now I got to draw a shape. So I'm going to draw a rectangle, and the upper left-hand corner's X position is going to be 0. Its Y position is going to be HUD height. All right, and then its width is going to be the width of my canvas, and its height will be the height of my canvas, but I'm going to subtract off the HUD height because I don't want to have the overlay show up on the HUD. So we're going to keep it off of this area. Let's refresh the page, and let's see if our hit overlay now shows. All right, so this is good. My light zones are working. Dark dim overlay is good. Let's get hit. Ooh, look at that red. That looks pretty cool. And our HUD is not getting any of that overlay. Now you can see right now the hit timer is triggered because we have the overlay, but as soon as I hit enter to re-illuminate, we're resetting that back to 0, so the overlay should be gone, and it is. So that's really good. So we don't have that overlay showing here. All right, mission number 4. I think our hit overlay system is pretty good. That gives us some good visual feedback like, hey, it's time to move. Get out of the way so you don't keep taking damage. All right, let's go to mission number 5. What's this going to have us work on? Mission 5. Oh, this is going to be a great mission. It says we finally get to apply damage to the enemies while they are in our light. So this is in our update enemies function. We're doing a lot in here. So we're checking to see if it's time to spawn an enemy. We're moving the enemy towards the player, right? They follow the enemy. And then if we look here, we are getting the enemy's light status. The enemy has a light status property now. So let's go check out our enemy object. If I go back to generate enemy data, they now have a light status. Did we have that in lesson 7? Let's just go take a look. I'm gonna go back to lesson 7 and look at my enemy object. Where is my enemy? Generate enemy data. See, we didn't have that property before. So we had to add some information to our enemy object to implement this new system. We are going to keep track of whether or not the enemy is in the light. And when we spawn an enemy, we're going to say, nope, they're not in the light at all. And now in our update, we are going to check to see if that enemy is in the light using our check object light collision. Remember, we were using this for the player, but now we are going to pass in the enemy's X position and the enemy's Y position. And this is going to return true or false. It's going to look to see if this XY value is inside of any of our light objects. And if it is, it will return true. If it's not, it will return false. And we'll update this property of our enemy accordingly. So if the enemy's light status is true, then that means they're in the light. It's time to deal damage. And so we're going to take the enemy's HP property. If you remember, we had set that to, I think, 100 when we created it, and we're going to subtract from it. So right now we're just subtracting 0, which is super weak, super lame, not powerful at all. What do we want to subtract? Well, I think we have an enemy light damage, right, per second. Didn't we say we want to just subtract like 20 pixels every second? So let's see what happens right now. Let's let those enemies come into our light zone. Enter the light zone, take your damage. Whoa, the enemy just disappeared. Where'd he go? Oh, it just disappeared again. Well, it's taking damage. It's just taking it extremely quick because remember, this is enemy light damage per second. We want to take 20 units of damage every single second, but we're not running this every second. We're running it by our DT per frame. And so DT is going to give us the time that has elapsed since the last frame. So this is going to slow that down for us. And now we will actually get our 20 damage per second when an enemy comes in. So let's see, 1, 2, 3, 4, 5. And they're dead. I count fast, but that works much better. So now it takes 5 seconds of being in a light source for the enemy to fully die. But you know what? The enemy's burning, right? We're trying to give this indication that the enemy's burning, but I see no visual effect that they're burning. So what I want to do is head to mission number 6. Mission number 6 is going to have us draw the burn effect. So this will look really, really cool. So we're going to change the enemy color when they are in the light to give visual feedback for damage taken. So if you look, we're saying the enemy's color, we're defining a variable called enemy color, and it's equal to the enemy's body color. That's just our red that we've worked with throughout our whole enemy system. And then we're putting that color in our paint bucket. But I want to change this. If they're in the light, I want to make it my enemy, enemy burning color. So let's just see what this looks like. Now when I create my enemies, they will be the color they will be when they're burning, which is white, right? And so there's my white. But here's the problem. I want them white when they're in the light, and then red when they're not in the light, and white when they're in the light, and red when they're not in the light. I have to dynamically change their color. And so we're going to introduce something new here. We are going to set a variable's value by asking a question. All right, so we're going to ask a question, and that question mark is known as a ternary operator. So we're going to assign a value to this variable by asking a question. A question is something that has to be true or false. And the question that we're going to ask is, what is this particular enemy's light status property? If it is true, we're going to set this variable to one value. So the question mark here indicates that, hey, we're about to ask a question. And if that question evaluates the true, we're going to use enemy burning color. So if the light status is true, we're going to set enemy color to enemy burning color. That's going to be our white. But what do we do if the question answered no or false? Well, we put a colon, and now we give the alternative answer. So if the answer was no, we're going to use enemy body color. And so this is a nice way to sort of set a variable's value based on a question using the ternary operator. So if enemy's light status is true, we're going to use this value. If it's false, we will use this value. And now we can dynamically change the color of our enemies based on the status of that variable. So let's look. There's our red enemy. Ooh, and now they are burning. And so, now they're back to normal. Now they're back to normal. Let's get them in a light source. They're going to die soon, and they're dead. Now, when they die, they just disappear, which is anticlimactic to say the least. I want to create particles and have their, have the enemy explode all over the battlefield. So let's look at mission number 7. Mission number 7, we are going to define and spawn our enemy death particles. So we're creating a new system here. We have to generate our particle data. Okay, so that's there. We've got to spawn our particles, and then we have to update our particles. So that looks like it is working quite nicely. I apologize really quickly. I noticed that I have something called a turret in here. We got to change that. I'm going to change that right now. I will make sure that you have the correct version. I copied this function from another program that I used that had particles in it. I'm going to put in an enemy and an enemy. I'm going to make that change right now. You should already have that, so you don't have to worry about that. But back here, we're going to generate our particle data. we're going to spawn our particles, and then we will update our particles. So this is no different than what we've seen anytime we've implemented a system. So right here, what are we returning? Well, we're going to return something that represents an individual particle. And so in this function, we get an angle. We're defining a variable called angle, which is somewhere between 0 and 2 pi. So we're randomly selecting an angle, and we're randomly selecting our speed. And so now we are going to define the enemy particle by creating this object. So we got to give like x, y, vx, and vy here. So it looks like everything else is set. Like the life in seconds is going to be our particle life seconds, which is 0.5. And the max life seconds is also 0.5. So this we're never going to change, and then this we're going to decrease. And as we decrease this, we're going to look at a fraction or a ratio between these two values, and it will like adjust its transparency. And then we also set the color of the particle, which is just the enemy's burning color. So we need to now set the rest of our particles here. So let's create this particle. If you look here, it takes in an enemy. All right, so we take in an enemy. So when an enemy dies, we need to know which enemy dies. And that's what I needed to change here. I was putting in turret here, so I changed that to enemy. So when an enemy dies, we're going to spawn a particle at that particular enemy's X position. And we'll spawn a particle at that particular enemy's Y position. Now, we got to move the particle in a random direction. So we've got Vx and Vy. So I want to get the horizontal velocity or speed and the vertical velocity and speed. So I have a speed, like maybe I picked a random speed of say 100, but I got to know what direction the particle is going to move in. So let's head over to the whiteboard here quickly, and let's just jot this out. So maybe I have a particle and I want it to move in this direction with a size of 100. Well, how do I get it to move in this direction? Remember, speed has two parts. Speed, well, really, I'll be correct here. Velocity has two parts. It has a direction, and it has a size. So the size, I'm going to say, is set. It's set to 100. But how do I get this direction? Well, the way I get the direction is I figure out how far we need to move in the x direction. That's our Vx. And I figure out how far I need to move in the y direction. That's our Vy. What specifies that is an angle theta. Now, we've looked at this relationship before, I think, in one of our earlier videos. There's a trig function called the cosine of an angle that gives us, let's see, our adjacent side over our hypotenuse. That is essentially the x value of our speed. And if we look, we have our y value is going to use sine. So I'll say the sine of my angle is the opposite over my hypotenuse. That's essentially the y value of our direction for our speed. So we're going to use cosine and sine of our angle here to get the directions. So let's minimize this and let's implement that. So I'll say, all right, Vx, I want the horizontal direction. So I'm going to take the cosine of my angle and I'm going to multiply it by our speed variable that we created. So I'm getting the size of the speed, the direction of the speed. And then we'll do this for the vertical direction, and we'll use sine for this. So the sine of our angle times speed. So again, the size of our speed and the direction of our speed in the vertical direction. And with that, I think our particle here is done. We've created that particle. So if we look, when we spawn our particle, we're going to take in an enemy. We're going to use a for loop here to spawn particles over and over and over again. So we go all the way up to our particles per enemy, which is 40, and we're pushing into our container, our array of particles, the object that we just created right here. So we're going to create, every time an enemy dies, at the enemy when it dies, we're going to create 40 particles. So that's pretty darn cool. Let's take a look. Where are we calling spawn particle? Let's just go see, when's an enemy going to die? Well, an enemy is going to die in, right here in update enemies. They're taking damage right here. And look, if the enemy's health is less than or equal to 0, we're removing the enemy and we're spawning our particles and we're passing in the enemy. So that system is in place. That system is working. Let's check it out. Let's kill an enemy and see those particles all over the battlefield. I'll create a bunch of light sources so our enemy is going to take damage. And let's see. Any particles? Whoa! That's kind of funny. They're sort of working. Are they working? I don't know if that's the correct behavior that I want. They're sort of moving just in the X direction. Their Y velocity is not updating correctly. They're just spreading out in the X direction, and they're not dying at all. It looks like they just stay forever and ever and ever. So we got to figure that out. I hope mission 8 fixes that issue. And mission 8 puts us in our update particle function. So we're calling update particles every frame of our game. And so what are we doing here? We're looping through our array of particles. And if you notice, we're looping backwards through the array. So we do this when we want to remove something from the array. We're eventually going to want to remove our particles. So I reach into the array and I grab the particle at position I. So I might be, 40 or 39, then 38, then 37, then 36 because we're looping backwards. And I work with that particular particle. So it says here, we want to draw and update the particle behavior, move the particles and fade them over time. So it looks like our X motion is working, right? Our particles were moving in the X direction, but they weren't moving in the Y direction at all. And so we're missing that line. So let's add that line in. We'll do that particle, we'll target its Y property, and we're going to add to it the particle's Y velocity, so Vy. But then we'll multiply by our time because this is how fast it's going to move every second, but we're not working with a second, we're working with our dt interval. So let's just check it now and see if the particles sort of shoot out both in the X and Y directions. They should. Oh, look at how cool that looks. But they just keep going. Like, look at this particle is still living. It's still alive until it goes off the screen. And I'd wager it's still living. It's still off the screen, just building up in our resources. So we somehow have to remove the particle. So if you look here, we've got a line that's asking a question. It says, if their life seconds attribute is less than or equal to 0, that's when we remove them. Well, when we defined this object, we set life seconds equal to 0.5. Nowhere are we reducing that. So in the update of our particles, after we move it, we have to reduce the particle's life second attribute. Particle.life seconds minus equals, and we're going to reduce it by dt. Now when we do that, our particle should eventually reach the kill condition in which it gets removed from that array. So let's check it out. Let's look for this guy. Can I stay right in this light zone? Let's see. Oh, and there we go. They disappeared. So that was pretty cool. It's like they popped like a firework. Pew. All right. I'm really happy. Now, if you notice, this is a kind of a neat thing. They are fading with time, which is super cool. So let's just check that out. Why are they fading? Well, if I go down to my draw event for our particles, draw particles. Okay, draw particles right here. What we're doing is we're looking at a ratio of their life seconds attribute to their max life. So as the particle's life seconds decreases, this fraction, this gets smaller and smaller and smaller and smaller and smaller. And we use that number to control the alpha, or the transparency of the particle, in a neat little way right here, if you're interested in looking at that. So that's why we get that really cool effect. And with that, I think our game is complete. Let's just see this game in action. So here we are. We're moving around. I'm zooming through. All right, I'm going to survive. I'm going to survive. I'm in the light. You can't damage me, but you will take damage. If I can stay here, particle, boom, blew you up. All right, let's see. Now we should hopefully be able to see the enemies getting faster and faster. That was not good. That was not good at all. Okay, I'm safe. I'm not safe. I'm not safe. I'm not safe. Okay, I'm safe. Our enemies are now spawning every, 4.14 seconds. We're at like 29% of the way to our maximum difficulty of our game. This is, whoa, that guy is definitely moving fast. Oh no, and I've died. All right. The last thing I'll just say is we still have our ramp displayed here. If you want to get rid of the ramp, you absolutely can at this point. The ramp was really there for debugging purposes. So to just comment that line out, if you go to, I think it's in Draw HUD. So I'm going to search Draw HUD. And in the Draw HUD function, I have my ramp readout. You can just comment that out. And now you don't get that debug screen. And so now we have our fully playable game all set. All right, I'm super happy with how this game turned out. We took an unplayable, broken game in lesson 1, and then in 8 lessons, we brought it to this final playable state where we have all of these systems working together. There's this synergy between them to create Glowfield. So I hope you enjoyed these videos, and I'll see you in the next one.